Hi there, students. I hope things are going well for you so far. This is just a short pre-class video to watch before class 3. If we go to the Quirkus page, the idea is that for every class, there's going to be two things. There's going to be the top hat questions, which are to be done during class, or I guess a little after. But then there's also the pre-class quiz, which is done on Quirkus. So for class 3, there will be 3 questions, multiple choice questions based on chapter 2, 2.3, 2.4, 3.3 through 2.6. So let's take a look at that. So section 2.3 starts with just referring back to this physics toolbox about vectors. So if you have an object which has been modeled as a point-like object, and you want to talk about its velocity, you want to write down an arrow, a vector for its velocity, you start the vector at the dot where the position is, and then draw an arrow which goes in the direction of motion and has a length that's relative to how fast the object is moving. So faster objects get a larger arrow. And so while a vector can be represented by an arrow on a page, in physics and math, we treat vectors as being like numbers in the sense that you can multiply them or add them to each other. So, and there's all these rules for how you do that. For example, if you add two vectors, there's this way of connecting them tip to tail. So a plus b equals a plus b. You can also use a parallelogram method for adding. You can subtract two vectors. And the trick there is that if you want to do m minus p, so vector m and vector p, every time they put a little arrow over it, that means it's a vector. That's the same as adding the negative of a vector. And the negative of a vector is the same vector, but in the opposite direction. So there's a lot of rules about it. Then there's also multiplying a vector. So if you can multiply a vector times a scalar is just a regular number. So 2c is just twice as long as c, but in the same direction. And then if you multiply it by a fraction, it's the same. D times a third is the same direction, but a third the length of d. And then if you multiply a vector by a negative number, you first reverse the direction and then change the magnitude by that factor. Section 2.4 is called quantities for describing motion. So we know what time is in seconds. Then there's position, displacement, distance, and path length. These are 4 different things that this book treats all differently. Those words mean very specific things. So it's important to read through this. Position would be like where an object is at different times on maybe an x-axis. Displacement is the change in position. It's usually the final position minus the initial position. Path length, and displacement is a vector. And then the magnitude of the displacement is called the distance. And then there's something called path length, which is how far an object moved to get from an initial position to a final position. And so this is all done in one dimension, so we usually talk about the x position. Section 2.5 is representing motion with data, tables, and graphs, which is going to turn out to be very, very useful. But basic idea is that if you have a stopwatch and a ruler, you can keep track of the time and the position, and then make a graph where the time axis is the horizontal axis and the vertical axis is the position, which in this case, in this chapter, is x. It's weird. The x is the up-down axis, and the horizontal axis is called time. And when you do that, so like if something's moving to the left, it might go to from 40 down to 4 or something. If x increases to the right, this graph of x versus time would be somebody moving from the right to the left, so like a negative slope. And the last section you need for this quiz is section 2.6, constant velocity and linear motion. So this is again, talking about things we've done. Velocity is rise over run on a position versus time graph. And they talk a little bit about relative motion. So it's good to read through this. There's a nice question, I think, that goes through a lot of interesting or really important an example. Example 2.5 has a lot of very important concepts in it. So your sister is running at 2 meters per second towards the mud puddle that is 6 meters in front of her, and you're an older sister, you're 10 meters behind her, running at 5 meters per second to try to catch her. And so the question is, do you catch your sister before she gets to the mud puddle and gets muddy? And so this is first solved in, I guess, the reference frame of the Earth by just trying to find when you intersect, like what time you hit your sister when your sister's running at a slower speed than you. And so they solve it that way. But then if you keep reading, what they do is they say, describe the problem using a reference frame with your sister as the object and the point of reference pointing towards the puddle. So relative to your sister, the sister is at position 0 and is at rest. And what's happening is that you're moving towards your sister with plus 3 meters per second, and the mud puddle is moving with a velocity of minus 2 meters per second from the sister's reference frame. You just subtract the sister's plus 2 from everything. So you were going at plus 5. Now in her reference frame, you're going at plus 3. The mud puddle was at 0 velocity relative to the ground. So in the sister's reference frame, it's moving at minus 2. So that's it for today's reading overview. Please have a look, and I'll see you in class. Bye for now.